Welcome back, grade 11s. As you guys hear, I did lose my voice. I don't know where to find it. So if you find it, please may you chuck it back to me because I'm really missing it. As you know, we're doing the lithosphere in physical science with Tracy. And already, I'm thinking that it's going to be pretty awesome, only because she mentioned gold. And we all know that I love gold. And yes, and we live in South Africa and Joburg and all those exciting things. For those of you who don't live in Joburg, because I know that there's people from all over Africa joining us. Bear with us today. That's why we're here. We're here to teach you more. And you're here so that you guys can learn extra. And of course, welcome to all our new mindsetters. Over to you.
Thanks, Kakli. Well, we might not do too much gold today, but
That's
I also
okay.
like gold.
That's
I'm into the whole minerals thing, so,
Yeah, so let's
gold,
do it.
silver,
Not so bronzy, but hey.
yeah, no, bronze isn't made. Diamonds.
Diamonds are a gold.
Yeah, no, absolutely. Well, grade 11s, as I said earlier, today's going to feel a little bit like a geography lesson. I'm hoping you've done some of this before, either in geography in maybe grade 8 or 9, and some of you right now are going, but I dropped geography. So did I. Okay, so please don't think I also dropped geography when I got to grade 10. I had no interest in it. But the honest truth is we can't just put our science out of context, okay? When the new curriculum was put together, it was put together in such a way that we can put what you're learning into a context so it makes sense. Because, just to learn random things for no reason doesn't make sense. And plus, as I said earlier, mining, and unfortunately mines have been in the news for the wrong reasons of late, but mining is so important to this country. We developed as a mining country. We live in Joburg, we film in Joburg, and we all know Joburg was founded on our gold mines, okay? In Mpumalanga and Limpopo, you have our gold fields, you have a lot of our other minerals. So actually, the old Transvaal, I'm so bad with geography, but the Northwest, all of those areas, those have a lot of our minerals. So those are really important parts for us. So a lot of our chemistry is built around that. So we're going to have to go into some detail as to where we get this from. So what I have here is a very simplified diagram. This is the Earth, okay, cut in half. This part over here, we cut a cross-section of it, and the Earth is about 12,750 kilometers in diameter, okay? So if we went from, let's do the purple, from here to here, that would be 12,750 kilometers. That's fairly long, okay? But if we then took a pie section out of the Earth and we went, okay, let's look at what it's made out of, because we know it's not a solid ball. We know there's lots of things around it. And we have spoken earlier, and you would have done it in grade 10 as well, about the fact that the Earth has a magnetic field around it, which really comes from its core. Now, this top part, which we're going to get into a little later, we're not going to do it in a lot of detail right now, but you are going to have to do the atmosphere. Now, atmospheric chemistry happens to be one of the things I really, really enjoy, but unfortunately we don't have too much time today. And what we have right over there, that's our exosphere, top end of the atmosphere, okay? Underneath that is the thermosphere. Ooh, if, of course, this board really doesn't like me, I'm just saying. Thermosphere, and again, it's my nails, I'm telling you. All right, let's just rub that out and do that. There we go, and try again. Thermosphere. And then we have our, and I'm going to run out of space. I should have made this bigger. Mesosphere, which is where we get our ionic storms, the aurora borealis that we see in the northern hemisphere. It happens in the mesosphere. Then we get the stratosphere. Okay. This is where planes fly. And then we have the troposphere. Okay? Now, that's all to do, and I don't think any of you can read that. That's definitely not my best handwriting ever. But anyway, that's the atmosphere. So that's all the stuff that happens above the ground. We're not worried about that. We're worried about all of this, all the stuff that happens at the bottom. Okay? Now, the Earth, if we start at the bottom, here we have our core. Okay? And, that's actually our inner core. Both of these parts are called our core. This one's the inner core. And our inner core is the middle Look at that. Surprise that, hey? The inner core. And the inner core is our iron. It is actually solid. Now, most of you go, how can it be solid? It is extremely, extremely hot. It is solid because of the pressure that the iron is under that makes up our inner core. Then we have our outer core. Those aren't, core's not that important to us. We're not too worried about it. Then we have our mantle and the upper mantle. And then we have the crust. Okay, so the crust is here. We live on the crust, okay? We live on the crust. The crust varies in depth depending on where it is, between 30 and 100 kilometers. Under mountain peaks, it will be about 100 kilometers deep. Under the oceans, about 30 kilometers deep. The mantle, okay, the mantle part here is actually magma. It's hot, it is liquid, okay, and the crust floats on the magma. Now, the fact that the crust floats on the magma is where we get the whole idea of continental drift. The continents actually do move, okay? It's also why we get what happens when we get mountains that get formed. The parts of the upper part of the crust actually dip below other parts, so they push other parts up, so we get a mountain. It's where earthquakes come from because the crust is moving. We have parts of the upper mantle moving. So this is quite a volatile part of the earth. All right, we don't really want to be around the mantle. It is extremely hot, and your mantle is about 2,900 kilometers thick. This part here, your middle mantle, this is 30 to 100, depending on where we're from. What we're concerned about today is the relationship between the crust and the upper mantle, okay? Because the lithosphere, and I should have moved this, let's do this. Your lithosphere, here's your definition, is the solid outermost shell of our planet, and it includes the crust and upper part of the mantle, and is made up of material from both the continents and the oceans. So the lithosphere doesn't just include the land, okay? It doesn't just include the sand and the actual hard part, the solid part of the earth, but the oceans as well. Now, we're not overly concerned about what happens in the oceans, except when it comes to things like our oil drilling. Often that happens outside at sea, which is why when they explode and we have problems with our oil fields, it becomes a problem because then they leak straight into the sea. Okay, now the core, which is the middle, is mainly iron. I told you that. Your mantle, when we have volcanoes exploding, it's material from the mantle that's coming out, which is a little scary. Okay, let's move on. What we need to talk about is the chemistry of the Earth's crust. Here we get to the exciting part. First of all, let's define the term mineral, because we talk about minerals, we talk about all sorts of things, and when we talk about the minerals that we need in our bodies and vitamins and that sort of thing, we're not really talking about the same minerals we mean when we talk about the Earth's minerals. South Africa is very, very blessed. We are a very, very mineral-rich country. We have lots of minerals, some of which are very valuable. Like we all know, we export a lot of gold. We actually mine a lot of uranium. We mine coal. And those are only the big ones that we know of. But we actually mine a lot of other things. Like there's an important metal called vanadium, which we mine and export, brings in lots of foreign exchange. We are very, very blessed as a country. We don't always think so, because, you know, the grass is always green on the other side, but we really, really are. But first, let's define what a mineral is. Minerals are natural compounds formed through geological processes. So it's not something we form through geological processes like time, weathering, when we have storms. You know, it's the whole controversy about how old the Earth actually is. The term mineral includes both the material's chemical composition and its structure, and minerals range in composition from pure elements to very complex compounds. So it's not a case of us going, well, you know, minerals can only be pure elements like oxygen and silicon and iron and whatever. They can be formed as complex compounds. Iron is often mined as iron pyrite, Fe2O3. Gold, despite the fact that we know we can actually pan gold and mine gold, actually comes out the ground in an ore, comes out the ground mixed with other things, but it's a very important mineral for us. But the important thing we need to get to is right here. Now this pie chart, which I'm really hoping you have a nice view of, and I'll put in some values in a second, this is just to give you an idea of how probably the 8 most important minerals we have and how they fit into context. Okay, so in terms of what we have here, this is color-coded. It might be a little more difficult to see, starting with oxygen, and this pie chart works anti-clockwise. Okay, I've made it a keyed pie chart simply because if I try to write in all the letters, all the labels onto the pie chart, it would have been really difficult to see. So, how much oxygen do we have in terms of percentage? Oxygen makes up about 46.6% of the total mineral composition we have in the world. That doesn't mean it's pure oxygen, grade 11s, okay? We're talking about oxygen that can also be in forms of other compounds, because if we're at 46.6% oxygen, pure oxygen, we wouldn't be so worried about the fact that we're cutting down our rainforests, that there's a hole in the ozone layer, all of that sort of stuff. Remember, this oxygen is oxygen that is actually in the form of oxides. Yes, we're talking about oxygen gas as well, but it's in the form of, oxides, okay? The next one is silicon, which is 27.8%. Now, I'm hoping some of you are going, but hang on, Tracy. Silicon is sand. Of course it's sand. Silicon dioxide, SiO2, is sand, everyday sand. But this is also by weight, not by number of atoms, okay? So silicon, we have a lot of sand, but we also have a lot of water, okay? So be careful there. Aluminium's the next one. Look at the difference. 8.1%. Iron, which we all know we mine quite a lot, is only 5%. Calcium is 3.6%. Sodium, 2.8%. Now, please don't get this confused. This is the percentage in our crust when we're looking at the solid part of our crust, okay? Not when I include the ocean, because obviously in the ocean, which is salt water, we'll have a much, much higher percentage of sodium. Then potassium is 2.6, magnesium 2.0, and everything else, gold, copper, vanadium, any of the other stuff we mine, okay, these are the metals, only 1.6%. 1.6%, which is actually quite ridiculous if you think about it, okay? Now, we can find these in their pure forms. They're very, very rare, especially things like oxygen, but we're more likely to find them bonded to something. In fact, oxygen we will find bonded. Most of these we find bonded to oxygen along the way, okay? Now, an example of one that we mine quite often is quartz. Quartz we use to make gemstones out of. That's a very pretty mineral. We can do a lot with it, but it has to be broken down. Okay, so briefly, and I know I'm busy overloading with the examples. Quartz, I've tried to find some pictures. Quartz almost looks like glass. Okay, it's a funny little mineral. Can often be mistaken for a diamond, so you've got to know what you're looking for. It's silicon dioxide. Okay, quartz is used for glass. It's used in electrical components. It's very good for optical lenses and in building stone. Obviously, we don't use it in that format. We refine it, but it is one of the ones we need to use. The next one is gold. Gold, that's what it looks like if you find it in nugget form. Okay, but we can find it in a form called graphite. And we find it in a group of metals called tellurides. Gold-bearing ore has a lot of other stuff with it other than gold. And what's been actually quite incredible is recently we've been recycling our mine dumps, which is great because it takes those eyesores out, especially for Joburg. When, man, you drive down the street, especially in the middle of Joburg, and you see all these mine dumps, they're all being recycled because there was a lot of gold still left in there, so they're taking the gold out. Hematite, Iron oxide, okay? We use this to get our iron. It's usually how we get it. It's an alloy of iron and nickel. Orthoglass, okay, which is actually potassium aluminum silicate. It's also known as a feldspar. We use it to get the potassium and the aluminium out. And then the last one is copper. Well, the last, and then there's the last one. Copper can come out the ground as pure copper, and we're going to do a little bit of history of how we use minerals. And the fact that it can be found as pure copper is really, really important. It's why we started using it. But it also comes out as malachite. Now, it's an unusual way to see malachite, and I happen to have some jewelry which is malachite. It's such a beautiful stone, and in fact, most of our malachite stuff comes from Zimbabwe. That's where I first saw it, was when I went to Zimbabwe. I won't tell you how long ago. Long time ago. And malachite is that beautiful green stone that you get in jewelry and stuff.
Yeah,
it's beautiful. But it's actually copper, which, guys, I'm hoping you remember copper. Some of you might have those copper bracelets, and it reacts with your skin and then goes green. It's not pretty, okay? But malachite has got that green tint to it. It's actually beautiful, beautiful stone. But it's a good way for us to get copper. And I think that is a very good place for a break, because it's a little bit of information overload.
Okay, let's have a break just so you guys can actually go through the information in your mind and on your pieces of paper. Someone said the breaks were too short. Well, I think that we must keep them short because there's so much for us to get through. And at Mindset, you know that we're always excited for what we do. So stay tuned. See you after the break.